long. Okay, so 3-1 exponential logarithm functions. So exponential function with a base of a, exponent has a variable. So f of x equal to a of x, or f of x is equal to negative x, which is 1 over a over x. So you guys should remember from a long time ago, when you have a negative in the exponent, you can make it positive by writing the base function and the exponent in the denominator of a fraction with the 1 on top. So rewriting it. So a couple things from the graph. When a is greater than 1, the domains are the same, negative infinity to infinity. The range is from 0 to infinity because it's everything greater than y equals 0, so it's everything above. So the range is 0 to infinity. It has intercepts at 0, 1, and it's increasing from negative infinity to infinity. So this is when a is positive. Oh wait, not positive. When x is positive. When x is negative, so the negative x, it's decreasing. So in this case, the increasing from negative to infinity to positive infinity, but it's decreasing from negative infinity to infinity. So it's going down. And this is when you have negative in the exponent. Uh, and they're all continuous, meaning there's no jumps. It's just a straight curve. Um, and then you can write a little note so you guys remember. So f of x. So you have 2 negative x. This is rewritten as f of x equals 1 over 2 positive x. It's not required. This part's only required if you're going to actually graph it by hand. So for number 3, it says graph the exponential function by hand, identify any asymptotes, y-intercepts, and determine whether the graph is increasing or decreasing. So we're going to graph it by hand. So we do that by having a table. I mean, honestly, the only one that you really need is when x is equal to 0 to find the y-intercept. But I always say to plug in a coordinate on the left-hand side of the y-intercept and on the right-hand side. So I'm going to plug -2 and +2. So 3/2 to the power of -2. So if you already have a fraction as the base, you can actually just re-flip it and put it to the power of 2. So this is just 2/3 to the power of 2. So if your base is already a fraction, you can just flip it. So when you do 2 squared, 3 squared, you get 4 over 9. Which when you're actually graphing, you could just write it as a decimal. So this is 0.44. 2/3 to the power of 0. This is the y-intercept is 1. 3/2 to the power of 2. This is 9/4, which will then be 2.25. This is what these 3 coordinates will just give me a quick rendition of what my graph is going to look like. So at -2, let's put 0.44 right there, roughly. 0, 1, and then 2 is 2.25. That's like roughly right here. So that's good enough to give me a quick graph of what the function will look like. And we have it like that. What else does it ask for? It asks for identifying asymptotes. So in this case, the asymptote is y equals 0. It's never going to cross the x-axis. Another thing it asks us for the y-intercept. 0, 1, or you could just write 1, but 0, 1. And it is increasing from negative infinity to positive infinity. So pretty easy, nothing too hard, just graphing, just plugging in values and simplifying it. So in this problem, we have negative x, so it's going to be the same thing. We'll just do -2, 0, and then the y-intercept being +2. So 3/2 -2, which is just +2, which we already solved for, which is 2.25. 3/2, -0, it's still just 1. This is 2/3 to the power of 2, 4/9, which is 0.44. So graphing it, -2, 2.25, 0, 1, and then +2, 0.44. So we have a graph that looks like this, roughly. And then just solving the rest of the problem as an asymptote. Y equals 0, y-intercept 0, 1. That's where it's crossing the y-axis. And then last but not least, it's decreasing from -infinity to +infinity. And we solved every bit of the problem. Does anyone have any questions? All right. Problem numbers, the rest of them says graph the exponential function by hand, identify any asymptotes, the y-intercept, and determine whether the graph is increasing or decreasing. Now, there's two ways to do this. One of the ways is to use translations by plotting the what's it called, the original equation, and then moving it left, right, or up and down according to the transformation. That one requires you to do a little bit of work, but it is helpful. The first thing you kind of have to know is if you have f of x plus a, this is horizontal. Horizontal shift, and then just know that when it's negative, you shift to the right. When it's on the outside, f of x plus k, it's a vertical shift. Okay, so for this problem specifically, this x plus 2 means I'm going to have a horizontal shift. Oops, let me do it right. To the left? Yes. 2 units. Okay. So in this case, this problem, since we know we have to shift to the left 2 units, where do you think the y-intercept will be? Nope. At -2. X has to be -2 in order for my y-intercept to be 0. Oh, wait, yeah, it is 9 to 4. Oh, my bad, yeah. -2, give me what? No. Oh, I'm talking about the y-intercept. Yeah, so the y-intercept would be right. Yes, it's shifting to yes. Yeah, sorry. Okay, I keep getting confused. Okay, yes. So for the what's it called? The x-intercept, sorry, for the y-intercept, x has to equal 0. So when I plug it in, so -2, +2. Right, yeah. So yeah, so the yeah, why I don't know why I had to bring it forward. But yes, so plug it in. So you have 3/2. 0 plus 2 is 2. So this would be 9/4. So in this case, my y-intercept would be 9/4, or in this case, 9 divided by 4 is that 0.22, 0.4? 2.25, sorry. 2.25 would be my y-intercept. And then when I plug in -2, yeah, you're right. Yeah. -4, -2, and 0. Oh, that's right. Yeah. Yeah, that would make more sense if you had, yeah. So we're shifting it to the left 2 units. So we'll do -4, -2, and then 0. Okay, so 3/4, 3/2, yeah, 3/2. 3/2. In this case, this will be 1. So -2 at 1, and then for -4. +2. Wait, is that right? No. -2. So I'll give you 0.44. All right. If you did -202, it's perfectly fine also. The one that it is important is always the y-intercept. So for sure, you need to have that in your coordinates. Okay, so now we can graph it. So -4.44. 1, 2, 3, 4.44. At -2, we have 1. And then at 0, we have 2.225. So it's right here. And then we have our graph. So pretty much we took our original graph and we shifted it to the left. And like, yeah, I guess so. Yeah. If you pick those 3 major coordinates, it's honestly would have been the original coordinates if you had drawn the pair function. So yeah, that works. Yeah. Works perfectly fine. Another thing you need to include, asymptotes. Y is equal to 0 because it's still on the x-axis. Y-intercept 0.49. Sorry, 9.4. And then it's increasing. And that is the complete. Give us a minute to write it down. Like, anyone have any questions so far? So you guys have to do these by hand. I know you can use Desmos to check the work. It's perfectly fine, but you gotta be able to do these by hand. Especially because when you get to the test, you're not gonna be allowed to use Desmos. But honestly, it's just plugging in values. All right. So for this one right here, +2 means we have a vertical shift. Up 2 units. Anytime you have a vertical shift, You don't have to change the x intercepts. Sorry, you don't have to change the x coordinates. You can just use -2, 0, and +2 because you're only shifting up and down, and that only is determined by the y output. So you don't have to use -4, -2, and 0. Okay, so for this one, you just plug it in. 3/2, -2 plus 2. So in this case, this is 2/3, +2, 4/9, 0.44 plus 2, which gives me 2.44. 3/2 to the power of 0, 1 plus 2, which will give me 3. 3/2, 2 plus 2. 9 divided by 4. 2.25, I think. Plus 2, 4.25. So -2 is 2.44. 0 is 3. And then +2 is 2 point, wait, 4.25. Okay. It's right here. Yeah, 4.25. And you should have a graph that looks like this. Now, anytime you have a vertical shift, your asymptote, your horizontal asymptote shifts with it. So since this is +2, our asymptote shifts. So now it's y is equal to 2, meaning my graph will never cross y equals +2. So if you have a vertical shift, just know your asymptote shifts with whatever the k value is at the very back. So now, so don't forget. I think I messed this up. It's -x, and I thought it was +2. I messed this up. This is incorrect. Yeah, it's negative, and I thought it was positive. I messed this problem up. Okay. Yeah, these have to be flipped. The y-intercept is fine. That doesn't change. But these ones do. This is -2 plus 2. I didn't realize it was -x. That's completely my fault. So this is 3/2 +2 plus 2. 9 divided by 4 plus 2. So 2.25 plus 2. So this is 4.25. That is completely my fault. This is -2. So 4/9 plus 2. So 0.44 plus 2. 2.444. Okay, I'll give you guys a minute to fix this one. Cause yeah. I didn't realize it was -x on the top. So when we graph it, -2 is positive 4.25. So these are actually switched. So this is important because our graph is no longer increasing, it's actually decreasing. So decreasing. And then the y-intercept is 0, 3. That's the complete and full answer for this problem. Anyone have any questions? So yeah, do be careful. If it's a negative x and you graph it positive x, it is considered incorrect. Okay, the last thing you guys need to know is compound interest formulas. These will be on your test as a quick refresher. So please make sure you have these in your notes. So the compounding per year is A is equal to P is equal to parentheses 1 plus R divided by N and T, where T is the number of years. R is your rate in decimal. And then P is your initial value. Is with what you start with. And then the couple things for the compounding in years. So there's a couple values. So annually. So N is equal to 1. Then you have monthly. N is equal to 12 because there's 12 months in a year. There can be weekly, which is N is equal to 52. And then you could also have a possibility of it being daily, which in this case, N is equal to 300 and how many days are in a year? 352? No, 365, 365. So these are the different possibilities that you can have. You could have biannually, which is N is equal to 2. Actually, let me look it up so I can give you all of them because you might have when you're compounding like how can yeah, infinite amount of times. While when you're compounding annually, is you're only compounding interest. You're summing up the interest according to your N. And number of times. Yeah, daily will probably never happen, but it is a possibility.
Actually, my favorite thing that I know, but
Why isn't I know there's biannually, and that's when I N is equal to 2, and you could have quarter. Oh, I totally forgot about quarter. N is equal to 4. I think that's all of them. Honestly can't remember if there's more.
always get bi-weekly, but you won't know if that's twice a week or.
Right, exactly. Yeah. Okay, we'll just stick with those. I think those are the most common ones. So it's asking you to fill out the interest form for each compounding for P is equal to 1,000, R is 6%, T is 10. So in the process of, because of notes, we'll do the first one and then I'll just give you the rest. So we'll do the first one, N is equal to 1. So all you got to do is just plot A is equal to 1,000 because that's what we started with. 1 plus my rate, 6% divided by N, which in this case, it's only 1. So this is annually. Parentheses 1 times 10 because it says in 10 years. So annually it would be roughly 1,790.85. So this is annually. Oh, now that's what it's called. It's not biannually. It's semi-annually. That's my fault. Semi-annually. That's the correct. When you plug in N for 2, you get, I'll help you guys just pull it out. 1,000, because you guys have done this already like a bunch of times. 1,006 and 11 cents. Quarterly, 1,814.02. And then monthly, 1,819.40. And then daily at 365, 1,822, I believe, 0.3 cents. And then for continuously, you have the formula here. The only thing you need is the initial amount and then the rate, and then for how many years. So you could also use 2.72 for E. It's an irrational number, but if you want to give it a value, it's roughly 2.72. So for the continuously formula, A is equal to what we started with, was 1,000 books. E to the power of R, which is in this case 0.06, and you're multiplying by how long? In this case, 10 years. So in 10 years at 6%, compounding continuously, roughly 8,202.12 cents.
Oh, I need the nonsense.
These are roughly if anyone's planning to invest or planning to buy a house and try to see how much interest you'll have to pay. You can use these formulas to give you, a estimate of what roughly you'd have to pay. So they're pretty good formulas. I know that you guys learned this in, I think, math 2 or math 3. I honestly can't remember what math class you guys learn how to compound interest. What? I can't hear you.
I said, I think whenever we use,
The E for the compounding continuously?
yeah.
Yeah. It's usually the other one that usually comes up a lot. All right, other than that, that is pretty much it. That is today's lesson. Just review how to graph exponential functions.